I am Dr. S. Anusha Kathyayani, Assistant Professor in Institute of Aeronautical Engineering. Today, my topic is on water technology. It is one of the module in engineering chemistry. So, here we are going to see the topics. The water technology outcomes are hardness of water, causes and disadvantages of hardness. So, the hardness of water topic covered here gives the topic learning outcomes like causes of water hardness and types of hardness, and then course outcomes finding the hardness in terms of calcium carbonate equivalence. So today my presentation focuses mainly on importance of water. First thing, the importance of water, the sources of water, from where we are going to get the water, the contamination. So what causes the contamination of water? So then classification of impurities. So generally the impurities present in the water causes a lot of problems. So here we are going to discuss in detail the classification of impurities and what causes the impurities of water and the effect of impurities. So the impurities present in the water, impurities present in the water generally affects lot of things. Like these effects on impurities in natural waters we are going to discuss in detail today. So the prominence of water. This is like general. Looking at water, you might think it is a simple thing. But water is one of the most important resources on the planet. So the pure water is colorless, odorless and tasteless. But it's not at all simple and plain, and it is vital for all life on earth. First, water is generally we write it as H2O. Here we contain 2 hydrogen molecules and 1 water molecule like this. So 2 H plus ions and 1 oxygen molecule. So this water is not simple and it plays a vital role in human life or for all life on earth. So where there is water, there is life. Where water is scarce, it definitely causes trouble. Life has to struggle. So without water, life cannot exist. So in totally on the Earth's planet, it was like 70% of the water is present. So it is making it a crucial resource for plants, animals and human beings. So the simple thing we can say is water is life. So the importance of water. So the major importance, it is the major importance to all living things. So even human body is made up of 70% of water. So up to 60% of the human body is water. So the quality of the water we drink is definitely important and it plays a crucial role in the human body health, in human beings' health. So the drinking water should be totally clean, pure and free of any diseases like any diseases causing microbes. Microbes are the tiny organisms which cannot be seen through our naked eye. It like maybe viruses, bacteria and fungi that causes diseases in human bodies, and therefore water should be properly treated and disinfected before we are using for the drinking purposes. So this water is also used as an engineering material for producing steam boilers to generate hydroelectric power, furnishing steam for engines and construction of concrete structures, and as a solvent in chemical processes. So this plays a vital role in not only for drinking and farming purposes, it plays a vital role in the industries like steam production, even in boilers to generate hydroelectric power and furnishing steam for engines and construction of concrete structures, and also as a solvent in chemical processes. Generally, the sources of water. There are 2 primary sources of water. One is surface and second one is ground. So the primary water is used for drinking, cooking, washing and farming purposes. The primary sources depend on rainfall and snow, which form a part of hydrological cycle. Hydrological cycle is nothing but the water cycle. There are 4 steps like collection, evaporation, condensation and precipitation. So the water in the river or streams converted into through the evaporation process, the liquid droplets are converted into the vapor phase or gas forms, then enters into the atmosphere. Where the condensation takes place, the vapor molecules are converted into the water and helps in the formation of clouds like mist or fog. So then from condensation, the byproduct of condensation is precipitation. Whatever the gas phase, cloudy and moist or fog collides and results in the formation of precipitation. So there, the precipitation, these water molecules enters from the atmosphere into the water bodies through the process of collection. So this is the water cycle or hydrological cycle. Again, the rivers, streams, lakes and ponds are the main form of surface water. So the surface waters like reservoirs and dams generates hydroelectric power and supplies water for agriculture and municipal and industrial purposes. So here the contamination of water occurs through this process. So for surface waters, actually these rainwaters are pure, but when entering into from atmosphere to the water bodies, it contaminated and mixed with a lot of gases present in the atmosphere, then it contaminates with the gases. And the river water, so the high dissolved salts with river water will generally have high dissolved salts with moderate organics. And the lake water, due to the constant stagnant water, constant composition of salts but high organics. And the last thing is sea water. As we know, the sea water will have high salinity, almost around 40 ppt. So the generally sea water will have almost 40 ppt of salts, total dissolved salts and pathogens and organics. So due to the high salt content, we cannot use sea water for all the purposes. So coming to underground waters, spring and well water. These are crystal clear but high dissolved salts and high impurity from organics. So here if we see, here this is a gas petrol filling station. So when it has leaking underground storage tank, what happens? The water here it mixed with the gases. So here the groundwater flow, the water flow will happen through the mixing of the gases present in the things and land water table. Here the groundwater what happens? The steam will mix with the most gases. So here like if you see water table here, it mixed with all the gases, so it got contaminated. And this is the surface water contamination. It may be through the mix up with the gases or through like leakages or from the surface water. If it have contaminants on the surface, when it falls on the earth, it mixes with the gases and got contaminated. So coming to groundwater contamination, if it is like well or like bore wells or wells, what happens? Due to the leakage in the tanks, here if we say like runoff, like agriculture, farming, we'll use pesticides and fertilizers. So what happens? When the water from the surface got mixed up with the pesticides and fertilizers and then into the underground water. So this is the way of contamination in underground waters and surface waters. So the water also affects on rocks and minerals. So there are 4 processes like dissolution, like mineral constituents of rocks such as sodium chloride and like sodium chloride NaCl and calcium sulfate CaSO4 readily dissolved in water. NaCl is nothing but the common salt which we use in domestic purposes. Like hydration. So minerals are easily hydrated, causing disintegration of rocks. What happens here? the water get dissolved. Some salts like sodium chloride and calcium sulfate, when it reacts with the water, these salts readily dissolve in the water and cause the disintegration of rocks. Disintegration is nothing but the breakdown. So conversion of larger molecules into smaller molecules, we call it as disintegration. So the effect of dissolved oxygen. So oxidation, here what happens, the dissolved oxygen in the water causes the oxidation of rocks and followed by hydration of rocks. First here oxidation happens followed by hydration. Here the oxygen is dissolved oxygen is nothing but DO. So what happens, the oxygen present in the water molecule reacts with the chemicals or rocks. Rocks, like the rocks is nothing but the different chemicals. Like if it is feldspar, this is iron containing rock. So calcium, magnesium, limestone, all are rocks with different chemical composition. So the oxidation happens here. So and hydration of rocks happens with the effect of dissolved oxygen. So the effect of dissolved carbon dioxide. So water containing carbon dioxide convert the insoluble carbonates of calcium, magnesium and iron to soluble bicarbonates. Here water containing carbon dioxide reacts with the insoluble carbonates. So which cannot dissolve in the water, the carbonates which cannot dissolve in the water of calcium, magnesium and iron to soluble bicarbonates. Here if we see feldspar is an insoluble carbonate. When it reacts with the water, H2O, it reacts with the water, it was converted into soluble bicarbonate. It was converted into soluble bicarbonate. Like feldspar is converted into kaolinite clay. So here if we see the pictorial representation, here carbon dioxide from the atmosphere, and here what we are telling, carbon dioxide. So the carbon dioxide from the atmosphere and the water from the rain reacts with the water molecules, reacts with the rocks and formation of silicate rock. So here calcium, again from sand is nothing but the silicon dioxide. So calcium reacts with the silicates and bicarbonates. So silicon dioxide and calcium carbonates are formed. So the classification of impurities, as we are telling, so the contamination is through even in groundwaters and surface waters, the contamination is going to happen. So the impurities are going to present in the water. So the classification of impurities, how we are going to classify these impurities. So the first thing is dissolved impurities. Dissolved impurities may be organic or inorganic. So the cations like calcium, magnesium, sodium, potassium, iron and aluminium and little traces like minor amounts of zinc and copper. So these are the inorganic salts. This causes impurities in the water. These are the main sources of impurities. Like these are the cations having plus charge. So this causes the impurities in water. So the coming to anions like negatively charged ions like chlorine, sulfate, nitrate and bicarbonate, iron and nitrous oxide causes the impurities in waters. These all are in dissolved form. So these are the dissolved impurities in water. So the gases like carbon dioxide, oxygen, nitrogen and oxides of nitrogen, ammonia and hydrogen sulfate causes the impurity or toxicity in water. So the coming to the organic, these are the what we told, these are the inorganic. Coming to the organic salts, like organic water products like amino acids, proteins and organic compounds causes the impurities in water. So the impurities in water, these are in dissolved that we cannot see with our naked eye. And these are like bacteria, that may be the bacteria, viruses, dissolved salts, industrial waste, chlorine, sodium. These things are present in the water as an impurities. So the first thing is dissolved impurities we have seen like anions, cations and organic compounds we have seen. So coming to the second thing is suspended impurities. The impurities are dispersion of solid particles. Here if we see these are dissolved. Here the suspension of solid particles that are large enough to be removed by filtration on surface and heavier ones settle down. Here the heavier compounds due to the weight, it got settled here. These are the heavier. So the lighter particles which suspend on the surface. See here again this is of two types. One is inorganic and organic. Inorganic is nothing but the sand and clay. Due to the heavier weight, it got settled in the bottom. And the second thing is organic, like oil globules, vegetable waste and animal matter that cause impurities, and it got suspended on the water. So again there are biological impurities like microorganisms, microbes like pathogenic or non-pathogenic bacteria or fungi, algae, all present in the water. Here, various impurities part some properties on the waters. So, from the point of industrial purpose, the characteristics and effects of impurities are as follows. Generally, for drinking water purposes, there are like certifications like BIS, Bureau of Indian Standards, or Indian Standards, and European Standards for drinking water. So according to their norms, like they will follow one number like ISO 190123, like some numbers will be there. So according to them, so they will follow the criteria like the color should be and pH. So for drinking water purposes, so they will follow some criteria. So it should be it should be color, odor. So one should, if we are going for packaged or potable water, one should satisfy all the criteria. Like the pH should be around 7 to 8. So the color should be light, odor free. So for potable and drinking water, it should be, the water should follow all these criteria. So as like this, for industrial purpose, we will follow all the 8 things like characteristics. First, color. Next, taste and odor. Next, turbidity and sediment. The fourth one is microorganism, followed by dissolved mineral matter. And dissolved mineral matter for all hardness, alkalinity, total solids and corrosion. And sixth one is dissolved gases, seventh one is silica content, and eighth one is oxidability. So first thing is, as we are going to see 8 characteristics, here 8 characteristics for industrial purposes like 1, 2, 3, 4, 5 followed by 6, 7, 8. So these characteristics in detail in the presentation. So the first thing is color. So the colors of natural waters range from pale yellow to yellowish brown to dark brown. So the color in water is due to metallic salts. Why color is happening in the water? Due to the salts dissolved in the water. So the metallic salts like iron, manganese and some organic substances like humus. Humus is nothing but the soil. Like find the soil, peat and algae weed. If algae, the green color algae which we see in from the stagnant water. So this is due to the this dissolved substance like organic substance, green algae in the water causes the color intensity in the water. So it varies from pale yellow to yellowish brown or dark brown. So the colored water is objectionable in the industrial activities. Why? Because if we go for the dyeing industry, they want some specific color. So if the already water we are using is already having color which interferes with the dye they are using in the water. So here in textile industry, suppose they are going to dye the light colors. So already due to the presence of these metallic salts, it causes problem in the industry. So definitely for industrial purpose, they should follow the characteristic like color. So here is the industrial activities like textile, paper and pulp and dyeing canneries. So the color is objectionable. They won't allow if the water is having colors. So the color intensities of water sample can be measured by like tintometer. So how we will measure? How the color is intensified? So we are using the tintometer and using platinum cobalt standard and expressed in terms of Hazen units. So here we are going to express the color intensity of the water which is using for industrial purposes is expressed in Hazen nuts. So the removal or reduction of color is done by coagulation, settling and absorption. So these three steps are going to use for removal or reduction of the color intensity in the water, like before going for the purposes, industrial purposes. So the next thing is taste and odor. So the taste, the presence of dissolved salts and gases impart bitter, soapy, brackish and palatable taste, which normally correlated with odor. So what happens? These salts present in the water causes taste, like different taste of water. If it is like soapy, brackish is nothing but the salt water or seawater. So what happens? The presence of these salts definitely relates to the odor. So bitter taste is due to the iron, aluminium, manganese sulfate and calcium hydroxide salts, and the soapy taste is due to the sodium bicarbonate salts. So the brackish water is nothing but the high salt content of NaCl. If it is more than 40 ppt, then we will call it as brackish. If the salt content, like sodium chloride content in the water, if is more than 40 ppt, like parts per trillion, here parts per trillion, more than 40 ppt, then it is called as brackish water. So what happens? High salt content in the water definitely results in the taste correlated with the taste. So coming to odor, same thing. Here domestic and industrial activities causes undesirable odor to water. So what happens? Industrial effluents which are released from the industries of organic or inorganic industries, what happens? The sewage discharge, presence of nitrogen, sulfur and phosphorus contains compounds, metal and pollutions like iron, so definitely dissolves in the water, cause taste or odor in the water. So the substances like algae, peat and bacteria also causes the change in the odor of the water. So the grassy odor, peaty odor, offensive odor, tarry and faint odor is due to all these salts present in the water. Either may be inorganic or organic compounds. Coming to the third characteristics, turbidity and sediments, it is due to the colloidal, extremely fine suspension such as clay, clite and finely divided matters. Sometimes also due to the microorganisms. Here also due to the microorganisms. It reflects the optical properties of water in terms of light scattering ability instead of transmitting straight lines. Actually, this was the how we are going to, if we see, if it is low turbid water, we can see from low to high. So the clear water like this, and due to the presence of turbid and sediments in the water, if we can see here more intense. This cannot pass the light through the water because due to the presence of what happens, the sediments presence in the water absorb light and cannot pass the light through it. So the same principle is used, and this turbidity was measured using turbidometer, also called as nephelometer. Here, nephelometer or turbidometer, and it was expressed in terms of NTU. Nephelometric turbidity units. Here if we can express in terms of NTU, like, and also called as Formation turbidity units. So what happens? Material which is so coarse that is rapidly tends to drop out of suspension is called sediment. Here when light passed through, here if no particles, it directly passes through the water. When light is passed through, presence of these turbidity molecules or sediments in the water, they absorb some light and results in the less light or less absorption. So the turbidity is measured in terms of NTU using nephelometer. So the microorganisms. Another characteristic is microorganisms. So the microorganisms are more abundant on surface waters because on surface, in soil, or even in rivers, ponds and lakes, what happens? Due to the stagnant water, more microorganisms, it is like a reservoir for more microorganisms. If you see here full algae, it is associated due to the stagnant water. It may be algae, viruses, pathogenic bacteria. What happens? All it mixed with the surface water. So organic growth in water occurs at ranging from 10 to 35 degrees temperature. So what happens? The moderate temperature to grow for the organic growth is 10 to 35 degrees centigrade. So they form coating in pipelines. What happens? Even in pipelines, what happens? So inside the pipe, it forms the organic growth. Thus reduce their carrying capacity of the, what happens? The carrying capacity of the pipe will be reduced. So again, formation of more layers in the pipe. What happens? The reduction in the flow of water. These organic growths are removed by settling, coagulation and filtration followed by chlorination. So the water having these microorganisms, like a microorganism is there in the water if we use it for industrial purpose. So suppose we are going to pump the water into the some boiler or some reaction tank. What happens? This organic growth in the water got layers inside the pipe. So the more formation of the layers, the more flow, the less flow, the water flow will be very less. So it should be microorganism free also for industrial purposes, and this can be removed by settling, coagulation and filtration followed by chlorination methods. So here dirt or bacteria after disinfecting, disinfection is nothing but the chlorination. So what happens? The chlorination here, all the bacteria will be removed and only chlorine will be there in the water. So dirt, bacteria, everything will be removed by the process of disinfection or chlorination. So the another characteristic is dissolved mineral matter. Here, so it involves all these four, like hardness, alkalinity, total solids and corrosion. So the mineral matter that affects the industrial application of water are the hardness and alkalinity. So what is hard water? Hard water is nothing but when it reacts with the soap or when it mixes with the soap, it won't give lather. No lather is nothing but hard water. So no lather. No bubbles. Like when it mixed with the soft water, soap is mixed with the soft water, it gives lather. This is soft water. When it mixed with the hard water, due to the presence of high calcium and magnesium salts in the water, actually soap is nothing but the fatty acids. So what happens? When it mixed with the water mixed with the fatty acids, and it may be oleic, palmolic, in detail we can see in the next presentation, and the fatty acids. So when it mixed with the fatty acids, these calcium and magnesium salts present in the hard water reacts with this and forms precipitate, like curd-like precipitates or curdles. So the precipitates are formed. So it won't give lather. Whereas in soft water, due to the less calcium and magnesium salts in the water, it won't react with the soap solution like a soap fatty acids, and it won't give precipitates or curds. Then mineral matter that affects the industrial application of water are the hardness and alkalinity. Alkalinity is nothing but due to the carbonates, bicarbonates, sulfates and phthalates are the main causes for the alkalinity. So the hardness is soap consuming capacity. So as we discussed, the hardness of the water is due to the formation or non-formation of lather. So like we are defining like hardness and soft water due to the soap. So this is the soap consuming capacity of the water sample. We can say simply as it is the soap consuming capacity of the water sample. There are two types of hardness, like temporary and permanent hardness. So the alkalinity of water is the total substances that increase the OH minus concentrations is nothing but the alkalinity of water. Again, this alkalinity is also two types, like carbonate alkalinity, total alkalinity. So total alkalinity is nothing but the carbonate and bicarbonate. It is called as the total alkalinity. So again, dissolved salts. Total solid content comprises of total solid content present in the water comprises of total dissolved salts. Nothing but the TDS that we generally test in the water. And it is expressed in terms of ppm, parts per million, or mg per liter. That means, so the present, suppose 200 mg, suppose we tested with the water for TDS, it gives 200, means 200 mg dissolved in 1 liter of water, or 200 ppm. So ppm is parts per million or mg per liter. We can express in terms of ppm or mg per liter. Here 200 mg, suppose if we test the water for TDS using TDS meter or conductometer using the we can give the value, then it can be expressed like 200 mg was dissolved, total dissolved solids were there in 1 liter of water. So corrosiveness of a raw water is determined by the impurities present in it. So the more TDS, the more corrosiveness. So under boiler condition, concentrated alkalis can attack steel. What happens? This water, suppose the more high concentration of TDS having waters are used in the industry, what happens? More dissolved salts will be present. So it reacts with the containers. See here, in industry more containers or pipelines are used. So the more salts reacts with presence of these salts reacts with the steel or iron used in the broilers. It causes corrosion. So under boiler conditions, concentrated alkalis can attack steel. So what happens due to this attack on the pipelines or broilers? So the loss of mechanical strength of the pipes. So it loses its mechanical strength, and pitting and perforation of metal and contamination of water, like the water which is used in the pipelines got contaminated with the corrosion present on the surface of the boilers or pipelines, which causes the contamination of water or interferes with the heat transfer. Even more TDS, more total dissolved solvents, we need to use more heat for boiling and more temperatures for effective boiling. So these TDS, like total dissolved salts, causes corrosion in waters. So the hardness. The hardness of water is defined as soap destroying power of water or soap carrying capacity of water. The consumer considers water hard if large amount of soap is required to produce lather. So how they will test? So they will test with the soap. If the consumer considers how they are going to test whether it is hard or not, even by quantification can be done with the titration method or the simple method to find out whether the water is hard or not. We can just apply the soap to the water. If it gives lather, it is soft water. It won't give lather and it forms curdles or precipitate. We can blindly say it is hard water. The hardness of water is caused mainly due to 4 dissolved compounds, like calcium bicarbonate, magnesium bicarbonate, calcium sulfate, and magnesium sulfate. Here, these iron compounds, magnesium and calcium compounds, if we are using this hard water in the industrial purposes, what happens? These tankers or boilers, due to these salts, it forms a corrosion on these layers. So whatever the solvents or liquids used in these boilers and pipelines, it got contaminated with these salts and resultant with the contamination of waters or solvents. And not only this, and it causes the perforation of the metal and it weakens because it loses its mechanical strength. This metal loses its mechanical strength due to the continuous reaction of these salts on the surface. So the presence of these compounds like calcium carbonate, magnesium bicarbonate, calcium sulfate and magnesium sulfate causes hardness in water. This is hardness. So if it is soft, here we can see the scale. Here pictorial represent. It is easy for your identification. So no salts, it is soft. High salts, like here if you see the arrow is downwards, like 0, 50, 120, 180, 250, 425. What it is like? 425 ppm is parts per million, or 425 mg per liter of salts are present in the water. So if it is less soft, this is moderately hard, and this is hard water. So there are others which are less important, like chlorides and nitrates. Generally they play, like calcium and magnesium can also cause hardness, but they occur generally in small amounts. So iron, manganese, aluminum compounds also causes hardness, but as they generally are present in such small amount, it is a customary note not to consider them in connection with hardness. So the chlorides or nitrates play a small role and even generally present in very less amounts. So compared to this, calcium and magnesium play a vital role in hardness. They causes more hardness in the water. So what are disadvantages? Why hardness should not be there in the water that we are using for industrial applications? So for domestic use, what happens? Hard water does not form lather. That's what we are discussing from last slide. Like it won't give lather because of the salts, high salts of calcium and magnesium. High salts like calcium and magnesium reacts with the soap. Soap is nothing but the fatty acid compositions. Like it reacts easily with this soap and is wasted. So hard water causes bad effects in our digestive system. What happens? More salts. Again, more salts like calcium, maybe magnesium, like iron, aluminum silicates causes digestive system, damage to our digestive system. Generally, when these type of salts, hot water mixed with high rich oxalate containing foods, the calcium present in the hot water or oxalate rich food from food gives rise to calcium oxalate. This is nothing but the stones which are forming in the kidney. This is the composition of the stones formed in the kidney is calcium oxalate. So the hard water which if we are drinking hard water, when we eat highly oxalate rich foods like even sweet potatoes, some categories are there with high rich of oxalates and causes the stone formation in the kidney. This is nothing but the calcium oxalates. So then the stone formation takes place in kidneys. So the hard water is highly not recommendable for drinking purposes. Then coming to cooking, the boiling point of water is increased due to the presence of salts. As we all know, the more salts present in the water causes the more fuel and time required for cooking. So the textile industry. So again coming to the textile industry, hot water causes wastage of soap because same reaction. So it reacts with the salts and then it causes the soap wastage, and the precipitates of calcium and magnesium soap adhere to the fabrics and cause problem. So when they are dyeing, the precipitates formed in the water, when what happens when they dip the cloth or fabric or like leather in the water, tannery industry, what happens? These precipitates formed due to the calcium and magnesium salts get adhered to the surface of the cloth or skin, which is used in tanning or textile industry. So it definitely causes a problem. These precipitates cause problems. So pharmaceutical industry. Coming to the pharmaceutical industry, hard water form undesirable products while preparing pharmaceutical products. Pharma products is nothing but the chemical compounds. So what happens? These active ingredients present in the pharma like tablets, syrups reacts with calcium and magnesium salts. So definitely cause impurities formation. So it is not recommendable in pharmaceutical industry, textile industry, even cooking. It wastes lot of fuel, and even for drinking we cannot use, and domestic use it causes the loss of soap. So the disadvantages of hardness. So if hot water is used in boilers, it may lead to boiler corrosion, scale and sludge formation, priming and foaming, caustic embrittlement, and in pharmaceutical industry. So what happens? So we know why hardness is caused in water. More salts. So what happens? Suppose if we see here this is the metal. The salts present in the water reacts are formed like a scale. It forms like a scale on the pipeline. What happens if you see here before salt formation, the water flow will from here to here, or the liquid or solvent flow will be here. Here the water flow is reduced to here. So what happens here? This boiler corrosion happened. This also causes impurities, waste of pipes or energy to pump the liquid or solvent or water from the pipelines. Here the corrosion. So actually in industries the agitators are used. Agitators is nothing but the mix up like fan like things to mix up the solution in uniform scale. So when due to the more salts, when water is there in the boilers, so due to the mix up, the salts got deposited on these blades. So again what happens? The already formed scales on the agitators got mixed up with the solvents and again gives impurities or corrosion. Corrosion is nothing but the iron oxidation on the blades. So all these things causes the impurities are this is not acceptable in the industrial level, because the scale and sludge formation on these blades or pipelines, if you see the corrosion, how badly it affected the boilers. Here if you see the agitators are the water like heaters, these are like heaters or agitators. So the scale or sludge formation we can see here on the picture. Here even in pipeline, domestic also, even in pipelines, the flow of water got more salts reacts with the this is nothing but the iron pipes. Now PVC pipes are used because of this corrosion free. PVC is corrosion free, so now we are using PVC pipes, polyvinyl chloride pipes, and here we can see here the sludge. The formation of corrosion or more salt formation, sludge formation. These are the scales, iron scales are formed on the water. So the next characteristic is dissolved gases. The carbon dioxide, the amount of carbon dioxide picked up by rainwater is very small. However, lakes, rivers contain high carbon dioxide due to decay of organic matter. What happens due to the stagnant water or due to these animals, the organic matter got decayed. So that results in when the organic matter is decayed, so decomposition results in carbon dioxide, more carbon dioxide. So it got mixed up with the water and gives more dissolved gases in water. So it may be the oxygen or carbon dioxide or nitrogen. Okay. So the oxygen. So dissolved oxygen is corrosive to iron, steel and brass. In the last slide we have seen this causes the more iron, steel and brass boilers causes corrosion due to the oxygen levels in the water, and if this also causes sludge, or when it was mixed with hard water, sludge or slurry formation in pipelines. So the nitrogen, it is inert. It won't react with the other gases like others. Like oxygen is going to mix up with the iron or steel. It got oxidized. Iron oxide is formed and it causes is nothing but the corrosion on the surface. So where is the nitrogen? It is inert and has no corrosive effect on metals. Here, the hydrogen sulfide, sulfur waters are corrosive with offensive odor. So again, nitrogen, whereas nitrogen inert, but hydrogen sulfides, so generally it exists in hydrogen sulfide form. The sulfur waters, what happens? It is like again corrosion. This not only corrosion, again results in the bad odor or offensive odor. So coming to methane, again due to the stagnant water, what happens? This waste, some animals or fishes present in the water excrete nitrogen or urea containing. Urea contains nitrogen. So what happens? This nitrogen or carbon dioxide are the resultant products. So again it may reacts with the water and results in the CH4. So this is when the anaerobic condition is due to the methane formation. So anaerobic condition. So inside the waters, like where here top of the water will have more oxygen. So under layers of the water, like when we go deep into the water levels, what happens? The formation of organic matter or the layers in the water reacts with the hydrogen, and the presence of hydrogen reacts with the nitrogen or methane, results in the formation of carbon dioxide, results in the formation of methane. Well waters contain methane because here well waters means deep waters, no oxygen over there. Like it is advisable to aerate water because aeration is nothing but the oxygen flow. So if we aerate, like if we aerate the water to prior to use, it can avoid to even we can avoid fire. Methane is nothing but it catches fire easily. It catches fire easily. So well waters or deep waters will react with the hydrogen, like nitrogen and carbon dioxide present in the water reacts with the hydrogen formation, results in the formation of methanes or nitrogen compounds. So before using water, well waters, that's why they will have some odor. Methane will have waters with the methane will have some odors. So to avoid this, the proper aeration is required. So if it is aerated, we can avoid the formation of methane in waters. So the next thing is silica content. Seventh characteristic is silica content. It is the concentration of silicic acid present in the water. So the presence of silicon dioxide in boiler feed water forms silicate scales and deposits in blades and nozzles of turbines. As I told, like turbines, nothing but like agitators or turbines are used in the industries. So what happens? The presence of more silica dioxide, SiO2 in the water. What happens? More SiO2 in the water causes scales or deposits on the turbines, blades or agitators which we are using for mix up or for boilers or tanks. Boiler tanks. So what happens? This causes a scales formation in the turbines, blades, nozzles of turbines. So the eighth characteristic is contamination, oxidability. Oxidability is the contamination of water by organic substance. So it is nothing but the organic substances causes contamination in the water due to the oxidability. It is expressed in mg of oxygen required for oxidizing 1 kg of organic substance. So we can express in terms of like mg of oxygen, mg of O2 per 1 kg of organic substance. So and also expressed in as an amount of potassium permanganate spent to oxidize the organic substance. This is a good oxidizing agent. That's why we will use in the titration reactions. So the oxidability of the water is expressed as an amount of KmNO4 potassium permanganate spent to oxidize the organic substances. So these are the 8 characteristics that causing the impurities that are used in the industrial purposes in the water. So these are the characteristics which we follow before here. These are the 8 characteristics we have to see before using for the industrial or domestic purposes in the water. So all these 8 characteristics are discussed in detail in the PPT. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.